Hi guys. The last time we had a workshop, we're having issues with the um, Sepolia faucet. Apparently, we discovered that it had to do with the IP address. I think if different people from, if different people from the same IP address are trying to get the test net, the faucets at the same time, it won't, for some reason, it won't distribute for those people. So yeah, so now before we start, we just have to go to our MetaMask. Yeah, slowly. Okay, I have enough leaks. I have enough leaks Sepolia here. Let me try the other account. This is mine. Yeah, this is me. So let's go to Sepolia. Sepolia, yeah. So you first go to Sepolia because this site is actually meant to mine Sepolia testnet, Sepolia it. So you can see the name here, Sepolia it. So you just copy your address and come here and then paste the address. Verify that you are a human being. So click on something that does not fit with this. The beer definitely. All right. Yep. Let's click. Continue. Snail. Verify. All right. So I've verified I'm not human. So start mining. All right. We've started mining. So for I think is it per day? I don't know. So you have a minimum. You can see there. They said the minimum claim reward. That means you have to mine up to 0.05 to be able to claim, and the maximum you can claim, the maximum reward you can claim is 2.5 Sepolia it. You understand? You can only claim 2.5 Sepolia each maximum, and the minimum you can claim is 0.05 Sepolia each. Yeah. So we just wait for this to mine. It takes a lot of time, apparently. So let's just wait. Yeah. And we haven't even got 0.001 Sepolia yet. We're still mining actually. So anytime soon we'll see our first set of Sepolia. Sepolia it. Yeah. Alright, we now have our first set of Sepolia hit. So let's just wait till we mine enough Sepolia to be able to claim reward the Sepolia, and when we've claimed, we'll bridge to the Lisk Sepolia. Yeah, so we've gotten 0.38 Sepolia it. Now we can stop mining and claim our rewards. So let's just claim. Yeah, so claim rewards. We'll have to wait for that to complete. All right, successful. You can see it has been confirmed. Now we can check our um Sepolia wallet, and we have 0.38382 blah blah blah. So now we can now uh go on to bridge from Sepolia 8 to this Sepolia. Sorry, let me refresh this. How do we do this? I think let me just do this. Lisk bridge. All right. So as the network's this bad. So yeah, we now you can see this is our Sepolia. Now we want to deposit, and we have our Sepolia it here. It's connected to my wallet already. So I have to just indicate how many Sepolia I, I want to transfer. I'm coming, let me check. I think this is the wrong account. Connect MetaMask. This is the wrong account. Let me connect to the right account. Let me switch the account on this app. Yeah, I want to switch to, yeah, let's connect to me. That's the one we are using before. So yeah, now we now see we have 0.38 Sepolia it. So now I want to convert it to Lisk Sepolia. So now we just have to put the amount of Sepolia it we want to convert, which is 0.38, and bridge funds. So we have to confirm the transaction. I have to confirm the transaction. Yeah, so confirm, and it has been transferred. You can go and check our, okay, still loading, still loading. When successful, you see the to come up. Yeah, that's our success right there. So it has been breached. So now the amount of each Sepolia will be transferred to our Lisk Sepolia wallet, which you will see here. Okay, open. All right. So this is our. You can see it has left the Sepolia. It's gone. So let's check our Lisk Sepolia. You can see and what's going on. We just breached. Okay, yeah. So this is 0.38 um Ethereum on our Lisk Sepolia testnet. So yeah, now we can now start with our smart contract and all the other stuffs. Okay, yeah, welcome. So now we are onto the smart contracts. The staking dApp needs three different smart contracts. We need the contract to create the stake token. We need another contract to create the reward token, and we also need the main contract that will be staking, that will be in charge of staking and giving rewards to the stakers. So yeah, so you can see on my Chrome we're having remix.ethereum.org. This is really like a code editor to help us create our smart contract with a more easier uh, experience. You understand, a more easier journey. It's a very developer friendly code editor, which so um, you in your remix you could actually test your smart contract. You can come here, test your smart contract. You could so we are giving fake ethers. You can check here. You can see we have different accounts, a lot of accounts with fake ethers here. So that's just remix for you. But although I'm still going to talk about deploying using Hardhat, because that's what we're going to actually use to deploy. But we'll be writing our smart contract code in here, then we'll move it to VS Code and deploy using Hardhat. Yeah. So now let's start our smart contracts. Let's start writing our codes here. Okay. So firstly, let's create a workspace, a new workspace. Let's call it, yeah. So leave the template in basic and let's call it what's it called? Lisk. Let's give it Lisk staked up. Yeah, staked up. What was that? What was that so hard for me? All right. So okay. Okay. Yeah. So you can see the template. You can see what we need, the scripts, the test, and all that. So in the contract, so we'll create a new file. We'll call it uh, stake token because we want to create our stake token. That's the token we're using to stake. So stake token dot Sol is like the extension for Solidity, if you know what I mean. So now we will have to specify the license for our Solidity for writing our solidity. So SPDX, SPDX license. I hope I spelled that well. Is this correct? LIS. Okay. I think this is not supposed to be here. Okay. License. All right. Okay. So identifier, this capital letter. Identifier. That good. All right. So what's the identifier? MIT. MIT. So, but let's just take this one out. I'm just trying to show you what we need. So normally, if you want to start your Solidity, you just want to you first specify the license and then the version of the Solidity you want to use to compile all this. So meanwhile you can just do this. So if you tap Pragma, it's going to bring that everything. So it's going to bring the the license identifier, and then we're going to give it the version, and the version is 0.8.0. 0.8.0. That's the version of the Solidity we are going to need. Okay, so yeah, the next thing we're going to do is import. We're going to import a library that was created for us. So Open Zeppelin. So this Open Zeppelin is a library, an Ethereum library that is a library that gives us Ethereum contracts to different Ethereum contracts, pre-written Ethereum contracts. It also provide utilities in which we can use to write our smart contracts. So Apple Zeppelin slash contracts slash tokens and slash ERC20 slash ERC20 also ERC20 dot so now ERC20 dot yeah, we have to put the semicolon because it's a static written. So we have to define. We have to tell the code that this is where our code is ending. That's why we have to put the semicolon there. All right. So now let's check the Open Zeppelin. I opened it already. So Open Zeppelin. This is the Open Zeppelin. You can see the smart contract library for Solidity. So if you click on it, you can get all the smart contracts we're going to need. So you can see we have Bootstrap smart contract, blah blah blah. Can see different ERC20. We have the ERC20 and 71 and 721. So different this thing. And let's copy this. You know what? Let's copy this. Let's just copy this and paste it. Control C. Let's close all these tabs. So we're going to paste this here. Oh, sorry, I forgot to grab the O. All right, so we're going to paste this here. Yeah, you can see the GitHub to that. So you can either open this or you can open this. So let's just open this. Yes, the one on the GitHub, and you will see the code there. So you can see the code to the ERC20. This thing. You can see different the pre-written code to the token. This is the token contract. So we're going to use the token contract. You can see we call it token here. So we're going to use the token contract. So this is the contract which was pre-written. You can see the name, the symbol. You have to give the symbol. You have to give the decimals. You have to give total supply. This is the balance of any account that like the balance of the tokens in any account. You understand? How many tokens does an account have? So to transfer tokens from one account to another account. So different ways, different things we could actually use here from creating the token. So all right, now we'll also let's just define our contract. So contract stake token is ERC20. Oh my god, how am I doing this always? ERC20, then open our block. And now we can say constructor uint 256. All right, so initial supply. So we're trying to give the initial supply. We're trying to specify the initial supply for this token. So ERC20, ERC20, yeah. Ah, God, I can see. All right, ERC20. Oh my God, ERC20. So now we are going to name our token. So we're going to call it stake token, and stake token, and this is the symbol. We're going to give it a symbol which is STK. All right. So let's open this now. We'll say mint. We want to mint these tokens. Mint. Um, messenger.sender. Initial supply. So yeah, okay. Yeah, so for those that are just new to Solidity, I know you guys should be wondering what am I writing. So let me just explain this little code of it and then we'll continue. So I did explain this license identifier and the version, specifying the version of the Solidity. I already explained what Open Zeppelin is, why we importing it, because we want to get this token contract, which is ERC20 dots. So, okay, so now this contract stake token is just it just we are not saying contract stake token is ERC20. We're just saying this stake token, this is our own contract that we're trying to create, is going to inherit the contract that's inside this ERC20. This, you understand? So you can see this is actually a contract. You can see ERC20 dot so let's just check. You can see, let me open it. You can see I want to is stake token dot so it does you can see the extension of Solidity there. That means it's a contract also, and I already showed you the contract. That's the code. Yeah, I showed you the code. Yeah. So let's go back, and the constructor so it's taking this constructor is just the the uh the function is, should I say a function? Let me just call it a function that will take place only once when it's being deployed. So once it's being deployed, you can't call this function again. That's just what's going to happen. So this constructor in this place, this constructor is going to give our token our token address. That's the contract, this contract address. Because when you deploy, it's going to get a contract address. So you're going to give this contract address a specific amount of initial supply, which we will indicate. The initial supply, which we will indicate. So you can see uint 256 on this contract you're having here. So this like sorry, I forgot to mention it, but Solidity is a typewritten. I would just say typewritten program, a typewritten programming language, in the sense that you, unlike in our normal JavaScript, we don't want to specify a string. You have to just call in our quotes, our double quotes, or our normal quotes. You understand, all the backticks. No, in Solidity, you just have to do strange. You understand, and you type what you want to type. You get, that's how Solidity works. You understand me? So for anyone that wants to do this thing, so that's just it. If you understand JavaScript, I think you understand what I mean here. So all right. So for the constructor, we gave it an initial we passed the parameter of initial supply, and for the ERC20, we are now arguing our this thing, our token name. We call the token, we are giving our token name. We are renaming this ERC20 token to be stake token. We are renaming it. You understand? So we are giving it a new name called stake token. We are not giving it another. This is like a symbol to our stake token, which is STK. You understand? So now we're not telling it to mint the initial supply for us to this contract address. You understand? That's the message the sender. So the contract address is now the sender, the one that's going to be asking for the initial supply. So we're now telling it. So once this is being called, you can't. I don't think it can be called again. Yeah. So that's just it. Yeah. Okay. So let's just set the decimals to what our token should be operating. So let's say function decimal. Alright, so we'll make it public, pure override, return, let's say return uint8. So we don't, alright, so okay, so return 0. Sorry, I've forgotten we did not do, wait, what's going on? And why we having error? All right, so we have to put the semicolon here. Solidity. All right, so that's just it. Yeah. So, a quick explanation of this function I just dropped. So, this function, we're just making it public. That meaning any address externally can call this address, and so this pure we just put is to make sure that the function does not modify the contract. You understand? So the override is to override the decimals in which this ERC20 initial ERC20 this thing is taken. We want it to override what is the parent contract is having before. So let's just return let it return in uint 8. You understand the data type we want it to return in. So this return zero means the decimal places we want it to be. You understand? So which is zero. We don't need to have any decimals. It should just be straight units. One, two, nothing like 1.2. You understand what I mean? So that's just it here. So let's move on to the reward token and creating the reward token. And apparently, it's just the same thing here we're having here. So we just copy and paste this in the reward token. And just Control C, Control C. So you can just you can just Control A, then Control C, then new file, then reward token. Wait, I just noticed that I spelled my stake token as stake token. So, all right, so reward token does so, and we just paste that because we are also trying to, yeah, I know what I'm doing. So we're also trying to create tokens that will be needed for the reward token. So, we're going to change all this stake token thing we're having. So, reward token, the definition reward token. All right. So, so this one change to reward token, and this logo will be RWD. So that's for reward. So it's the same thing you get. So that's just what we need now, and we can move on. Yeah. So I know when I was coding, you guys would have noticed something was loading around this side. What was that? Like, what's that? Why is it loading? Why is it that anytime I type something, it's loading? So this is actually our compiler. So the compiler is just like a configuration something in the sense that it's going to process the code, our code that we write here. This is our normal human Solidity code that we've written here. It's going to process it and analyze the code, and when it analyzes it, it will then uh, generate the code to optimize it, then generate the code into machine language in which the EVM will understand. If you know what EVM is, you can check that on Google. So EVM is like the machine in charge of Ethereum this thing. So it will generate that and just return our ABI and bytecode for us. So yeah, that's just it. So the machine language will become bytecode, something like that. So you can check what those means. So all right. So that's what the compiler is. So you can come here. When you come here, let's say on your stake token, you can on your stake token, let's click on our stake token here. So when you're on your stake token, maybe let's go back to contracts. So let's go back to this place. All right, so come to your stake token. You're on stake token now. So you can now come to your compiler and just compile stake token, and you see when it's compiled successfully, it's successful. You can see you've been given your ABI and your bytecode. So that's just what it is. So, but mine compiles automatically. So you can see the reward token. All right, so you can see this. So you can just click on auto compile and you compile everything you have been writing automatically. So that's just what you do. All right. So let's move from here. We'll move on to our staking contract. That's the main contract that is creating the staking dApp itself. You understand? That's staking, that's withdrawing, that's the rewarding the people that are staking. So yeah. So let's move on. All right. So for my own satisfaction, please, I would love to let's change this stake token to stake token. Yeah, just yeah. Actually, you can name it anything you want to name it, but just for my own satisfaction, let's change it to stake token. All right, so we save that. Now let's create our staking uh contract. Staking, that's the file, a new file. Staking dot so. So this is what will be in charge of our dApp. actually. So this is the staking contract. This is what we use to stake and do other things here. So okay, so let's call out the license and the version of license and version. Okay, so I'm going to change this license here. We're not using this license. We're using GPL 3.0. So for the version, we'll be using greater or equal to uh, 0.8.2. Okay, there, well, less than 0.9.0. So that's the version we'll be using for this. All right, so let's move on. Sorry, let's move on. All right, so I'm going to import Open Zeppelin. I'm going to import Open Zeppelin. Open, I think I get it. Yeah, let's get that. Okay, all right, Open Zeppelin. Contract. We contract token. ERC20. Okay. ERC20 also. So this ERC20 also is just another contract that helps us manage our staking. That will be importing the transit guide here. So this one is called Retransit Guard. This Retransit Guard is that it helps our code being protected from retransit attack. So if you want, let's check what retransit attack means. Retransit attacks. So, alright. So a redundancy attack happens when a function is externally invoked during its execution, allowing it to be run multiple times. So, if this function is being run multiple times, it will just spoil the normal state of our contract. So, I think let's see demo expansion. Yeah. So this a transfer attack happens when a function is externally invoked during its execution, allowing it to be run multiple times in a single transaction. Imagine let the function being run multiple times in a single transaction. That means it will perform that. Let's say we have to reward somebody and it's performed that multiple times. That's going to be rewarding the person more than once. So that's not a good thing for our code. So this typically occurs when a contract calls another contract before it resolves. So all right, so let's go on. Import open Zeppelin contracts. Uh, so this one's from the utils. All these are contracts. They are just help us. They are just like stuff to help our contract be a better contract. You understand? So this is save math. Save math. Although we're not going to be using this right now, we'll use this later in the code. So let's just comment this out. Let's just comment this out. All right. So okay, let's just comment that out. Oh, you know what? No need. Just call it back. So let's go. Contract staking is is retransferred. Transferring is retrans guard. All right. Then let's open. You know what? I'm confused. Control C, Control V. All right, that was the correct spelling. All right, it's retrans guard. So we are going to use save maths. So that save math is just it's just utils to help our mathematics, our arithmetics in the contract. It gives security. It's also a security guard to our contract. You understand? For save calculations, something like that. Yeah. So save math. Uh, so you can see we're not telling it for you int 256. Yeah, so we're good to go. IERC20, that's this contract. We're now saying IERC20 public. Sorry. So you can see we're bringing in our staking token here, and we're telling it should be what's going on? Control C, Control V. Oh, okay. We didn't put this here. All right. Okay, so IERC20, IERC20, also public. Then we'll bring in our this thing. So these are variables. We're just setting variables here. So staking reward token. Okay. We are good to go. Unit. So these are the variables we are doing. Public uh, constant. Sorry, I put too much space here. Wow. So I want to set the reward rate. All right, to be equal to 10. Sorry, okay. Um, so what other this thing do we need? We need what other variables do we need? We need our total stake tokens here. Okay, so um, you int it should be private this time around because it's only for our it's only for our sorry, it's only for our contract. So it should be private total stake token. Okay. The next one will be our you int public. Oh, okay. And we will be reward. Oh, sorry. Reward. Per token staked. Next will be our last updated time. So we you int public last update time and we are good to go. All right. So what other this thing do we need? We need our stake balance, we need our rewards, and we need our user reward per token paid. So will be this one is we're going to be mapping. So we're going to map through the oh sorry. So okay. So let's not waste time. I'm just going to copy this down. I'm just going to duplicate this because yeah, this almost the same thing I'm going to need here. So this one will be rewards, and this one will be a user reward per token. So all right. So the other this thing we'll be needing is staked. We'll be needing staked, withdrawn, and rewards claimed. So even okay. All right. So let me duplicate this. So we shouldn't be wasting time on writing all this. So just duplicate. So if you want to duplicate, you can just shift alt down. So that's how you duplicate. Yeah. So we've done for staked, right? So withdrawn. Okay. And the next one should be reward claims. Reward. Yeah, reward. Mm, yeah, we're done with our we're done with our variables. So these are the variables we're going to be needing. All these are the variables we're going to be needing for any other thing. So cool. Now we'll just do our constructor and all that. So all right. So I discovered that we misspelled one of the variables. That's reward. This reward per token staked. We spelled it staked instead of stored. Sorry. So it's our tokens are being stored here. So reward per token stored. Please. All right. Now let's go. So let's define our constructor. I said it that our constructor is the uh usually the function that helps our that invokes okay let us say invoke all right that invokes our smart contract, you understand, when we are deploying it. So it's the one that takes what we need. So address, yeah. So we need two things from this for this constructor. We need the reward and staking token and the reward token address. So reward token
All right. So that's good. That's good. Uh, yes. Sorry. Take what? Taking. Uh-huh. What token is equal to? So we're trying to get our stake token address here. All right. So equal to. Okay. Cool. That's cool. That's cool. All right. Now let's define the functions that we need. We're going to need function. We're going to need the word per token function. We're going to need that. So it should be a public function. You returns. You return a new int unassigned integer. So int. Okay. What's next? What other function we okay? We need we need a function of end. That's the function to get what our user have end. So function. So we need the person's account, the address account. So public user the returns your int also. So we're expecting to return in your int. What's the next function? All right. So this time it's a type of modifier updating this thing. So it's a function, but this one is just used to modify our smart contract whenever we are doing something. So update reward. You can see it's used to change something in the storage. So update reward. We need the address. All right, the account, and yeah, all right. So anytime you're using a modifier, you will need something like this. Yeah. So let's go. What's the next function we'll be needing? We need our stake function. That's the function in charge of staking. So to be in an amount you int. Oh, sorry, amount. You can see what I mean by type rating. So this amount is going to be in numbers. So unassigned integers. For not telling you that this is going to be in numbers. The amount is going to be in numbers. So all right, let's go. Going to be external because coming from an external smart contract. I mean external address. Um, no, okay. No chance of date reward message dot render. Okay, just oh, okay. All right, I've completed that. What's the issue? What's the issue? Okay, we'll do that soon. What's the next function? Don't mind the error. We'll fix that. We need our withdraw. So this is the function that will be in charge of the withdrawal of any token the user has staked. Amount. All right. Say withdraw. All right. Oh, sorry. External. Um, it, yeah, we're good to go. Good to go. Good to go. Good to go. So, and the last function we'll be needing is the get reward function. So this one is just the one, the function in charge of distributing the reward to people that are staked. So which one? Yeah, non-return, non-return. So let's start computing these functions with what they will need to become what you want them to become. All right. So if state token, so our total state tokens is equal to 0, return reward per token staked. All right. Uh, sorry, our semicolon is not here. All right. So total. Let's get our total time which we've staked. So is equal to block dot timestamp. So the total time in which we staked, that's the current time minus the last updated time, which is the time we stored before. So your image rewards equal to, oh, I'm always forgetting this semicolon. All right. Our reward rate multiplied by total time. There you go. Given multiplied by our total time. All right. So that's good to go. So we want it to return reward per token stake. Per token stored plus uh our total rewards. That's our total rewards. So I'll just copy this so that we won't have any error. Sorry, control V. Uh, so divided by our total stake token. All right. So the next function is to get our end tokens. Return our stake balance, which will be needing our account. All right. So multiplied by, oh, let's open a bracket. So reward per token minus user reward per token paid the account. So our reward per token minus user reward per token paid from this particular account will be multiplied by the stake balance from this particular account. So let's go. And yeah, we need this. Now our modifier, what will update our rewards. So we're going to get our reward per token speed per token storage, then which will be reward per token. All right. Sorry. We're going to get our last updated time, which will be equal to block dot timestamp. All right. My legs. We're going to get our rewards, which will be from this account. So what we've earned. All right. So we're just updating things. You understand? All right. So is our user reward per token paid and from our account, which will be equal to the reward per token stored. What's going on? Okay, so we've now put our semicolon here and we are good to go. Our semicolon good to go. So we've done our modifier. That's for our update reward. What's the next? Okay, so this is our stake function. The one we need to stake. We use to stake our token. So I'm going to require a particular amount. So which should be greater than 0. So if the amount is not greater than 0, I should be tell the person amount must be greater than 0. All right. So semicolon total stake token. Our total stake token plus equal to amount. All right. So our total stake token will be equal to this amount from the that we've inputted. So our stake balance is uh, okay. Uh, sorry. All right. Um, we're still having this return stuff. Oh, success is equal to staking token dot transfer from MS number. We need our address. It's amount. Okay. So require. I have not put, I have forgotten to put the success transfer field. So that is the success or our transfer has failed. Cool. So what's going on? What's going on? Okay. Why are we having this non-return stuff?
Hmm. Okay. Let's see. Let's see. Why are we having this? Why? What's this? Retransit. You know what? It's coming from this retransit guard contract. So let's just copy that and we'll copy that. Then we'll paste that in let's paste it in a new tab. All right. Let's check the GitHub. Let's know what it's about. That's it. Okay, it's non-rain. Okay, I think I missed the N. Okay, so let's just copy that. Control C. Okay, all right. Control V. So yeah, that's it. So copy this. Control V. Control V, and we pasted everything there. Yo, okay, we are having some kind of errors here. So this staked is the staked here. This staked, and it's supposed to be capital letter. Put it in uppercase. So state. And we are good to go. Yeah. So, what's the next function? The next function we're going to talk about our withdraw. So we're going to do our withdraw function. So what do we need in our withdraw function? All right. So let's go. Require. Let's get the amount. Going to require an amount when we're withdrawing. So, all right. The amount was greater than 0. Uh, amount was greater than 0. Then move on. What's the next? We need our total stake token, which is minus 1 equal to. Okay, so we're going to minus from our amount. So what's next? Our semicolon, please. So stake balance Save balance. Which will be taking our messenger dot sender, our message of sender to messenger, our message of sender, and yeah, semicolon. Uh, let's emit the withdrawn. Let me just send, I think. Okay. Send. All right. So, what are we expecting? A boolean of success. That means it's either true or false. You understand? Which is equal to stake token dot transfer from the transfer a control Z, not a transfer, please. Okay. Cool. All right. So we are going to do for our get reward function. So new int, we're expecting new int reward equal to. So from our reward, the rewards of our sender, that's the person that's sending this to require the reward should be more than zero. Rewards to come. All right. So immediately we've sent it, so it gets our. We're going to set the rewards back to zero so that the person will not have to be able to claim rewards twice. You understand? So it's rewards claim. So we're going to emit reward claim. What's the user? We want our sender and our reward. So send this to the user. Okay. So it's our message. Transfer failed. Either it's a success or transfer is failed. Yeah, I'm good to go. Yeah, having we didn't pass this year. We need this year too. And we're able to go. Everything's cool. So yeah, everything's cool. No errors, nothing. We're error free. So let me now explain the whole smart contract for you guys. So okay, so let's talk about the constructor. The constructor, we already said it. I already said it. The constructor is what initializes our smart contract and before being deployed. You understand? So you can see we're requiring the staking token, the reward token, and then which I mean the stake token address and the reward token address. You understand? So before our this thing is being set off, it's going to require a stake token address and a reward token address. So this stake token address will be the one in charge of providing stake tokens, while the reward token address will be the one in charge of providing reward tokens. You understand that kind of thing? So now, in the stake reward per token, reward per token, I think I'll just do a little bit of calculation to help us understand more on this. So let's bring this here. So now imagine, so yeah, we are just checking if the total stake token is equal to zero. I'm coming. All right. Total stake token is equal to zero. It's just it's a variable stored before. So we're just checking if the total stake token is equal to zero. So now imagine we have a user, we have an address who is taking just one token. Understand? So the total stake token. So I'll call that total stake token T, total stake token TST, total stake token will be equal to one. You understand? So since it's equal to one, it will skip this function. But if it was equals to zero, it will just return the reward per token stored, which at this moment, this is just a new user, and the reward per token stored, reward per token stored is equal to zero. So which is just zero. You understand me? So now, okay, reward per token stored, which is just zero. Now, if the person staked one, you understand me? Which is if the person staked one, it will skip that reward per token stored. You understand me? It will skip this condition. You skip this condition. Sorry, you skip this condition. Then we are going to get to this place where the total time. We're going to calculate the total time. So let us say the person started staking around. That's the last updated time. The person started staking around let's say 12:01. You understand me? 12:01. 12:01, and the person stopped at 12 12:32. That's the total of, I think that's the total of, wait, okay, let's say 12:00 and 12:20. All right, 12:20. So he ended. We're not this. We call this function at exactly 12:20. You understand me? So we are going to get 20 seconds. 20 seconds. That means last the last update time, which is 12 o'clock, which the person staked, and minus the present timestamp. That's going to be 20 seconds. You understand? 20 seconds. 20 seconds. Let's call that 20 seconds. That's time. Let's say total time. Total time. Total time. All right. So the total time is 20 seconds, right? So now we want to calculate our total rewards. The total rewards we are calculating, let's just say the reward rate. So our reward rate, we remember our reward rate was 10. You understand? So let's go back. We have 10. Our reward rate is 10 times, okay. So total reward equals to reward rate 10 times multiplied by our total time, which is 20, which we have 20 seconds here. So 10 multiplied by 20 will be 200, which is equal to 200. Sorry, let me just do the equal to here, 200. All right. So now we're not saying it should return reward per token stored. Our reward per token stored. Our reward per token stored was zero. So which will be zero. You understand me? So our reward per token stored is zero plus our total reward, which is 200, divided by the total stake token. Since it's only one person that is taking, and we only staked one token, so the total stake token is only one. So the the uh the reward per token here, this reward per token will now be equal to zero plus 200, which is equal to 200 tokens. You understand? So that's the reward per token. So because this person staked only one token, the person is getting 200 reward per token. So, all right. So let's say we have two stakers with one token staked each. We have two stakers with one token staked each. So we okay. So our total stake token becomes two. We have two stake tokens now. So our the reward per token stored still remains zero. That's RPTS will be equal to zero. You understand? So, okay, let's say both of them started this taking from, let's say started taking last time update, last updated time. Update time will be equal to our last update time will be equal to will be equal to, let's use the same as updated time, which will be equal to 12, 12 o'clock. And the other one will be, so the current timestamp will be like timestamp will be like 12:20. So our total time will be equal to 12:20 minus 12 o'clock, which will be giving us 20 20 minutes. Oh, sorry. Let's put this in seconds, right? So sorry. 120. All right. I wanted to do this in seconds. All right. So, all right. So we'll be doing, sorry. Okay, let's correct this too. We'll be doing 1, 12, 20. All right. So this is 20 seconds. All right. So which is equal to 20 seconds. All right. Now we've gotten our this thing and we want to calculate our total reward. So that will be the reward rate equals to total time, which is 20 seconds. So the reward rate will be 10 times 20, right? So we'll be doing total reward is equal to 10 multiplied by 20. All right, which is going to give us 200. All right. So what are we going to do? The reward per token stake, then the reward per token will be equal to reward per token stored. All right, reward per token stored, which is our initial reward per token stored was 0. So 0 plus, what's the total reward here? 200. 200 rewards divided by total stake token, which is 2 tokens. So 0 plus 1 plus 200 divided by 2 is equal to 100. So we now have 0, we now have 100 tokens. So we now have 100 reward per token staked. You understand? So this is 100 reward per token staked. That means each taker gets 100 token. You understand? They're going to share the 200 tokens that this is going to disperse. That's how it's going to be.